16 elements, which is also known as oxygen family and chalcogens. Why they are known as chalcogens? Because they are ore forming found in the earth crust with sulfur and oxygen. The Greek word derived from the past derivatives. The general electronic configuration of these elements is Ns2np4. The elements in these group have 6 electrons in the outermost shell, 2 in S and 4 in P. Now coming to the next level of the properties, that is physical state and molecular structure. Group 16 elements, oxygen is in gaseous state. When we move down the group, we will observe the elements are found in solid state too, and sulfur is also found in the various allotropic form in solid state also. Why oxygen is only in gaseous state? Because oxygen is found in the diatomic state and it has ability to form p pi multiple bonding, while others is having p pi d pi bonding. So as we move down the group, the occurrence in the physical state will be in solid state. Atomic and ionic radii follow the general trends that down the group, atomic and ionic radii generally increase due to the increase in atomic number. Density down the group decreases due to increase in size. Melting and boiling point also of group 16 follows a general trend that down the group increases due to increase in the atomic number. So from oxygen to selenium, you can say the atomic number increases and melting and boiling point also increases. The ionization enthalpy, as we know, that depends upon the atomic size and nuclear charge. So as we move down the group, the valence shell increases. As a result, it is easy to remove the electron from the outermost shell. In the same manner, when we move down in group 16, the ionization enthalpy decreases. Now the next property, the electronegativity. Group 16 elements electronegativity will be slightly higher than group 15 due to the higher nuclear charge, and down the group this electronegativity decreases due to increase in size. Oxygen is the second most electronegative element of the periodic table after fluorine, the entire periodic table. This is due to its small size and high electronegativity. Now electron gain enthalpy. Electron gain enthalpy as depends upon the electronegativity. Down the group due to increase in sizes decreases. But oxygen electron gain enthalpy is slightly less than sulfur. This is due to one fact that oxygen is having very small size and it bears some inter-electronic repulsion. So due to the smaller size, atomic size of oxygen is having an inter-electronic repulsion for the incoming electron. As a result, its electron gain enthalpy becomes slightly less than sulfur. Now coming to the next property, that is oxidation state. Oxidation state depends upon the number of electrons present in the group outermost shell, and two categories of oxidation state is been observed in group 16, that is minus, negative and positive. The negative oxidation state, which is exhibited by mostly all the elements, is -2, which has also been shown by oxygen and other elements in the group. Positive oxidation state from +2 to +6 is exhibited by all, but oxygen exhibit +2 and +1 only in two molecules, that is OF2 and O2F2. These are the only two molecules in which oxygen exhibit the positive oxidation state. Otherwise, oxygen do not exist in positive oxidation state. This is because of its small size and higher electronegativity. Now coming to the next, metallic character. Metallic character down the group increases due to increase in size. So as we move down from oxygen, sulfur, non-metals, and then selenium and tellurium, they are semiconductors, and polonium becomes metallic in character. This is simply due to the increase in size and increase in number of shells. Now the next property is catenation, means ability to form a bond with itself. It depends on a tendency of having small size and high electronegativity. So it is only shown by oxygen and sulfur. So oxygen and sulfur has having a greater tendency towards catenation, as they can form a bond with itself because of their small size and higher electronegativity. Now the next is allotropic property, able to exist in various allotropic modifications. Oxygen and sulfur shows the property of allotropic forms. Sulfur allotropic properties is slightly higher because of its stable size and electronegativity. Selenium also exists in 6 allotropic forms. Tellurium, polonium also show allotropy. The tendency of catenation will be more in sulfur in comparison to oxygen due to the unstable oxygen-oxygen single bond because of its small size. Now coming to the compounds of group 16. Compounds of group 16 is, the very first compound is hydrides, means bonding with hydrogen. The structure will be the angular structure of hydrides in group 16, as we can say here, that all the elements of group 16 will have two lone pairs and a bent structure because of the presence of two lone pairs on the central atom. So here is the molecule of H2O, then H2S. So all these molecules follows the same structure, but only differs in the bond angle. Down the group the bond angle decreases due to increase in size. The physical state and volatility: when we move down the group, the molecules occurs in liquid and solid state, while H2O occurs in liquid state, though it should occur in gaseous state. This is only because of one reason, that H2O has hydrogen bonding. And the volatility also follows the same order, as we can say the highest is in H2S. And down the group it decreases due to increase in size. Increase in size increases molecular forces. Now question arises that why H2S is having higher than H2O. H2O is having H bonding, which is decreasing its volatility, and H2S is not having any hydrogen bonding, so it becomes the most volatile hydride of group 16. Now boiling point down the group increases due to increase in size, but H2O has highest due to the hydrogen bonding. So here, coming to the next, another elements is being the thermal stability. Thermal stability down the group decreases due to increase in size. The bond enthalpy decreases and it becomes easy to break the bond. Acidic character of the hydrides down the group increases due to increase in size. The release of H plus ions becomes very easy. Reducing character of all the hydrides down the group increases due to increase in size as bond enthalpy decreases. Now the next compounds will be halides. All group 16 element forms halides, and oxygen is also forming an halide with fluorine, and fluorine being more electronegative, that's why its fluoride is known as oxygen difluoride. While other group 16 elements forms halides in +2 oxidation state to +6, but hexahalide is not exhibited by oxygen because of the absence of vacant d orbital. Rest other halides exist, and tetrahalides means in +4 oxidation state, hexahalide in +6. In tetrahalides is having just distorted bipyramidal structure, and in hexahalide the octahedral structure. Now coming to the next oxides, all group 16 elements are forming monooxide, dioxides and trioxides. Here depending on their stable oxidation state. The oxidation state is most common is +4 and +6, but the stability of +6 down the group decreases